All right, so let's take a look at number 1 here on worksheet 3. All right, they give us, amazingly enough, a function defined by an integral. Let capital F of x equal the integral from 2 to x of f of t dt. Does the 2 really matter? Not really, okay? Because as long as it's a constant, that means that we've got a function of x. Now, when does the 2 matter? When we evaluate, okay? So the graph of little f on the interval from -2 to 6 consists of 2 line segments and a quarter of a circle, as shown at right. They don't always tell us that, but a lot of times they do, because they don't want you to miss it because you just misidentified. You know, you didn't recognize that as a quarter of a circle or something. Okay, so quite often they'll tell us that. But they expect us to be able to figure out whether or not the region underneath is, you know, a triangle, a trapezoid, a rectangle, a quarter circle, whatever. So first, find capital F of 0 and capital F of 4. Okay? Now, since we only need to find 2 of these, I'm not going to bother, well, I take that back. I was going to say I'm not going to bother rewriting this as a function without the integral. I can't anyway. They didn't tell me what f of t equals. Okay? So, to find f of 0, I'll put a 0 right there, evaluate that integral. To find f of 4, I'll put a 4 right there, and evaluate the integral. So, let's do that. F of 0. So if there's a 0 right there, we'll have the integral from 2 and then going backwards to 0, and we'll have to put a negative in front of it, make it the integral from 0 to 2, and then find the area of that triangle. Does that seem like the right way to approach it? Good, because it's the right way to approach it. So, here's my work down here. Let's see, let me put a screen up here. So, capital F of 0 equals the integral from 2 to 0 of f of t dt. But we don't like the lower limit and limit of integration being to the right of the upper limit. That seems weird. So we make that negative, and then the integral from 0 to 2 of f of t dt. And by the way, here's the good thing about, or one of the things I like about going back and doing these worksheets at the end. Even if you got lost at some point during the year on taking integrals, can you still work these problems? Yeah, even if you're the worst at finding antiderivatives, if you're the worst in the world at finding antiderivatives, you can still do these problems. Okay? So some of you need to pick your effort and your outlook back up. You can do these. So keep the negative in front, and then we have that little red triangle. Well, the area of a triangle is 1/2 base times height, so 1/2. And then what was the base? You can look on your paper. 2, and the height, 2. So altogether then we have an area of 2. And it's got a negative sign in front of it. So you with me on capital F of 0? All right, then define capital F of 4. So let's go back and look at the figure again. Let me get rid of the red. We put a 4 there. So it's the integral from 2 to 4. So it's this. So what shape is this? It's a quarter of a circle. It's a fourth of a circle. What's the radius of this circle? 2. So capital F of 4, which equals the integral from 2 to 4 of f of t dt, is going to be the area of that fourth of a circle. So it's 1/4 pi r squared. So it's 1/4 pi times 2 squared. Well, 2 squared is 4. 1/4 times 4 is 1. We get pi. So can we do as many of those as they give us? We should be able to. Now, depending upon what the limits of integration are, we would have to add two regions together. You know, maybe find the area of the triangle, which would have been negative in this case. So in other words, if they wanted the integral from 0 to 4, wouldn't we just add -2 and pi, and that give us the integral? Ooh, be a +2 then if it started at 0 and went to 4, wouldn't it? Yeah, almost blew that. Okay, but we can do that. We can piece them together any way we want. So let's look at the next part. Determine the interval where capital F of x is increasing. All right, remember how this works. If a function is increasing, its derivative is positive. If the derivative is positive, the function is increasing. Okay? So, what's the relationship between capital F and little f? Capital F is the antiderivative of little f, which means little f is the derivative of capital F. So, where is the derivative positive? Right? It's positive here, right? It's still positive, but I kind of blew by something here. What's the derivative at 0? 0, is 0 positive? Nope. What's the derivative at 4? 0 is 0 positive. All right, so the derivative is positive between 0 and 4, and then from 4 to 6, which means capital F is increasing on the interval from 0 to 4 and 4 to 6. And then I wrote, so actually from 0 to 6, I need to be real careful with that, don't I? But here's what I got to think, okay? Since the derivative was 0, all right, here we get into definitions. Since the derivative did hit 0 at 4, let's not worry about 0 so much because that's where we're starting from. But in the middle of our interval from 0 to 6, our derivative is 0. But then it's positive again. So did our function ever start decreasing? No, it didn't. So it depends on the definition. Our function is always going up, and then for one brief coordinate, the derivative is 0. And then it keeps on going up. Well, what happened there? I don't know. Something like that, maybe? Okay? So I can still say it's increasing the whole time because it never started. As long as increasing means never decreases, then I'm good. Okay? That's where the 4 of you that went to the very first Saturday session where Monique talked about how, what I've always said, if the function is increasing, the derivative is positive, and if the derivative is positive, the function is increasing. She said that's not right. Yes, it is. But she's right technically, okay? Because if the derivative is 0, the function could start decreasing right after that. We wouldn't want to say that it's still in. I mean, you see what I'm saying? So there's the one exception there, where the derivative is always positive, 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 0, positive, positive, positive. If you look at the graph of that function, it's going to look to you as if it's always increasing, because it never decreases. It's one of those things where it's a little minute point that I'm probably beaten to death and should just ignore, but that's the way it works. Okay? All right. Oh, and by the way, stuff like that, that's mostly notes from me to you. Okay? What was the difference they said in those sessions between, what was it, justify would mean name the theorem. That's not the theorem, but that would be the reason why. So if you have to justify, then you need to say something like that, don't you? And if it doesn't say justify, then you don't have to say that. That's what I got out of it. Is that what you guys got out of it? Okay. All right, so let's see. What's question C ask us to do? Find the critical numbers of capital F and determine if each corresponds to a relative minimum, maximum, or neither. Okay. We know what critical numbers are. Critical numbers occur when equals 0 or does not exist. And other people seem to think students always forget that does not exist. I don't think you guys will forget that does not exist. We've said that so many times, I think you'll remember that. All right, so if we look at our graph, this is the graph of the derivative. Well, it always exists. There's not any holes in it, right? There's no asymptotes. There's no gaps. It always exists. And we've already mentioned the 2 times it equals 0. So what are the 2 critical numbers? 0 and 4. Now, I'm going to write all this out in just a second, but let's do our thinking. At 0, to the left of 0, our derivative is negative. To the right of 0, our derivative is positive. When our derivative changes from negative to positive, we have a... No. We have a critical number. We've already established that. We have a relative minimum. And if you'll recall, they want you to say it that way, don't they? That the derivative changes sign. Because if you just say that the function goes from decreasing to increasing, they consider that to just be a restatement of the definition of minimum, which isn't our book's definition of minimum. Okay? So we'll need to say that. And I don't know if I wrote it that way or not. We'll have to see. And then, is there a relative extreme value when our, t coordinate equals 4? No. So here's what I wrote. First, I'm justifying it all. Critical numbers occur when the derivative equals 0 or does not exist. Therefore, x equals 0 and x equals 4 are the only critical numbers. And you need to state that. I mean, I'm assuming on all of these we need to justify our answer. Okay? If they don't tell you to, you can just state them. All right. Now, we've figured out the answer. Let's say it. There's a relative minimum at 0. So when x equals 0, or x equals 0 yields a relative minimum since f, little f, the derivative, changes from negative to positive. And according to what we've been told in these Saturday sessions, I don't need to say the rest of that sentence, do I? Say it for me, would you, please? Because to me, it shows you that you realize that a negative derivative means the function is decreasing, and a positive derivative means the function is increasing. So just for me, just for old time's sake, throw in there, which means capital F changes from decreasing to increasing. And then we did not have an extreme value at 4. How come? Doesn't change signs. There is no extreme value at x equals 4 since f is positive on both sides of x equals 4. And then just for me, and capital F is increasing on both sides. All right. Everybody caught up to me? One thing you definitely need to do on free response is don't assume they can read your mind. Okay? You don't have to write a book, but when you know the reason, tell them. Right? If you don't know the reason, if they didn't ask you to justify it, you don't have anything to worry about. Okay? And if they tell you to justify it and you don't know the reason, you need to try to bluff them a little bit. Talk about something, talk about a derivative being something. All right? You know the words to use. Okay? Well, I mean, the point being, if they say justify and you don't put any justification at all, you know you don't get the point. All right? Justify something. All right. Find the absolute extreme values of capital F of x and the x values at which they occur. Justify your answers. What's different between a relative extrema and an absolute extrema? Endpoints. Absolute requires endpoints. So we need to figure out what are endpoints. -2 and 6. We need to figure out what's going on at -2 and at 6. All right, so let's figure it out then. So, part D. Extrema occur at critical numbers or the endpoints of the closed interval. Now, we've already eliminated capital F of 4 because there was no extreme value at capital F of 4. Now, at capital F of 0, since there's a relative minimum, maybe there's an absolute minimum. Can't be an absolute maximum there. Okay? And then we need to see what's going on at the other ends. All right, so let's evaluate and let's find capital F of -2. Remember our definition of our function. I didn't write it again, but maybe I should have. Capital F of x equals the integral from 2 to x of f of t dt. So capital F of -2 will be the integral from 2 to -2 of f of t dt. I don't want to go from 2 to -2, do I? So I want to put a negative in front and then go from -2 to 2 of f of t dt. So let's look at that graphically. From -2 to 2. Well, look what's going on here. Divide this up into two pieces. And we'll get that integral. We'll get that integral. And what are they going to do to each other? They're going to cancel each other out. Okay? We need to show that, though, don't we? Since we know how that works, let's show it. Maybe we could get away with just writing the answer down. But since I know how to do it, I'm going to show them. All right? So I keep the negative out in front. Then I break that up into the integral from -2 to 0 plus the integral from 0 to 2. Okay? And then, I think I've shown them enough. Okay? If you don't think you've shown them enough, then give them the numbers. What are the numbers? -2 for the first one, a +2 for the second one. So we would have a negative out in front, bracket, -2 plus 2. And then we know they're good there to know that's 0. Okay? It all depends. From what I've seen over the years, looking at their scoring guidelines, since all free responses are 9 points, if there's just so much crammed into a problem where they easily have 9 points out of it, that may not cost you. On other problems, they kind of have to stretch it to get to 9, then that'll probably cost you. And of course, you don't know that when you're working the problem, So again, if I know it, mention it. Okay? And see, they may look back here where we'd said there was no extreme value and assume at that point that we've said so. I don't know. Because when you listen to them talk, the graders, they'll always talk as if they're just dying to give away points. But then when you see the scores, no, they aren't. They don't give points just because the handwriting's nice. I mean, it doesn't happen. So, So if you know it, as long as you have time, I don't see how it hurts to mention it. Okay? All right, so f of 0 we've already found. It's -2. Did you wonder why we found these at the beginning? And by the way, if you did notice, oh, f of 0 is in there, I've already got that. Maybe f of 4, they're trying to sort of trick you into trying to use f of 4, maybe? Maybe? Okay? And then capital F of 6. So according to the definition of the function, that's the integral from 2 to 6. Let's look graphically what's going on from 2 to 6. So from 2 to 4 was that quarter circle, and then from 4 to 6 is a big old triangle. Add those together, right? So we make that the integral from 2 to 4 of f of t dt plus the integral from 4 to 6 of f of t dt. Now, we have already found the integral from 0 to 4, or from 2 to 4, which was the quarter circle. It's pi. Okay, so don't have to rework that. And then triangle, 1/2 base times height. The base is 2, the height is 4. And so we get pi plus 4. Well, the absolute minimum is the smallest of these three numbers. So what is it? The middle one, -2. The absolute maximum is the largest of these three numbers. What is it? F of 6. So, and again, I know stuff, I want to tell them. I don't want to say the minimum is -2 without telling where it comes from, because I know where it comes from. Definitely don't say the minimum is 0. The minimum occurs at 0, right? By using this notation, we're giving them whatever they're looking for. We're telling them what the absolute minimum equals, -2. We're telling them where it occurs, 0. So I like that notation because it tells them both things no matter which one they're looking for. Okay? So f of -2 is the absolute minimum on the closed interval from -2 to 6. Capital F of 6 equals pi plus 4 is the absolute maximum on the closed interval from -2 to 6. Do I need to restate the interval? I don't think so. And I sure don't want to lose a point over something I knew and just didn't write down. Right? I'm going to lose enough points on things I don't know, right? All right, we ready for E? Find the x-coordinates of the points of inflection, or of the inflection points of capital F of x. All right. Points of inflection occur when? When the second derivative equals 0 or does not exist. Now, let's think about that, because they don't give us a second derivative. If a function changes from increasing to decreasing, well, how do I want to say this? If a function changes from increasing to decreasing, its derivative changes from positive to negative, negative to positive, right? So, if the derivative changes from increasing to decreasing, didn't the second derivative have to either equal 0 or not exist there? You following me? So, since our derivative goes from increasing to decreasing right there, doesn't its derivative have to either equal 0 or not exist right there? So isn't that a possible inflection point? And then doesn't the same thing happen right there? Okay? So inflection points occur when the derivative changes from increasing to decreasing, what did I say, or vice versa. In other words, when the second derivative changes sign. They like the change of signs things, don't they? We've had a couple of people talk to us about saying that. Okay? Because which way are they looking for me to explain that? I don't know. So I'm going to try to explain it. I'm sure that one of the graders would say, you don't need to say blah, blah, blah. All we're looking for is this. But I don't know which this they're looking for, and neither do you. Okay? So, Capital F of X has inflection points at 2 and 4. Now, in part E, no, that was E. In part F, they're going to ask us about the concavity itself. So remember, and it was on the first handout I gave you. 3 things go together. F concave upward, F prime increasing, F double prime positive, all go together. F concave down, F prime decreasing, F double prime negative, all go together. So, when our F, which is so let's just call that the derivative because it is. That graph is the derivative. When that derivative is increasing, then the capital F is concave up. When the derivative is decreasing, capital F is concave down. Now, part F asks us, determine the intervals where the graph of capital F of X is concave down. Capital F of X will be concave down when its derivative is decreasing. So, from who to what? 2 to 4. Not where the derivative is negative, where the derivative is decreasing. The only time this derivative is decreasing is right there. Right? So, capital F of X is concave down whenever its derivative is decreasing, which means its second derivative is negative. I doubt they're wanting you to talk about second derivative since they don't give you a second derivative. That's me guessing. Okay? Therefore, capital F of X is concave down on the interval, open interval, from 2 to 4. All right, so if you can remember, concave up goes with derivative increasing, concave down goes with derivative decreasing. You can do E and F, right? Okay, so you got to remember that. Any questions? All right, I want you to finish worksheet 3. And have fun with that.